Condorcet method. The Condorcet method, sometimes called pairwise, is a voting system in which the winner is the option that, when compared in head-to-head competition with every other option, is the preferred option. Step 1 is to compare option A to option B and determine the number of people who prefer A to B and the number of people who, conversely, prefer B to A. The option with the most votes is the winner. Step 2 is to compare option A to the next option, so option C, and you repeat that process. Did option A get more votes or did option C get more votes? We repeat that process for option A for all the other options that are available, so we test option A against every option. Then for step 3, we move on to compare option B to every other option. So we now need to compare option B to C and option B to D, and so on, until we figure out whether B is the more popular or whether it gets beaten out by some other option. And we repeat that process for every possible combination of options. So every option goes head-to-head with every single other option. At the end, for step 5, we can declare the winner. The winner will be the option that never loses in head-to-head competition. The advantage of this method is that it's the most rigorous and ensures that the greatest number of people will be satisfied by the outcome as possible. The disadvantage is that there can often be no winner and it's complicated to implement. Let's look at an example of how this actually works. So like the previous two methods, we have a ranked ballot type of situation. So there are, in this case, we've sort of got 3 different ballot rankings. So 16 people ranked A first, B second, and C third. Similarly, 14 people ranked C first, A second, and B third. And finally, 10 people ranked B first, A second, and C third. Let's see how the board account works out. First thing we're going to do is see how option A did versus option B. So looking at this first ballot, we see that we've got 16 people who voted A over B. So those 16 people preferred A. In the second column, there are 14 people, and here again, even though A was their second choice, they still ranked it higher than B. So from that second column, there are 14 voters then who still preferred A to B. Looking at the third column, we can see that B is ranked higher than A, so none of those voters preferred A to B. So in the A versus B battle, A got 30 votes and B only got 10 votes. Therefore, we can say that A versus B, A wins. Now let's move on to the next battle, A versus C. Using that same approach, in the first column, we've got 16 voters. They ranked A first and C third, so clearly they prefer A to C. So there are again 16 votes that go to A. In the second column, we've got 14 voters, but these ones put C first and A second. So in that case, those 14 votes would go towards C. The third column is going to be the deciding factor in the A versus C battle. This time, however, we see they've got A is ranked second and C is ranked third, so their preference is for A over C. So those votes will go to A. So once again, A wins. So in this small election, A versus B, A wins, and A versus C, A also wins, so that means that A is the overall winner because it defeated both B and C in head-to-head competition. Let's look at another example. We've got more options this time, A, B, C, and D, and there are 4 different ballot types this time. So again, we'll start off with A versus B, and looking at the first type of ranked ballot, we can see that A outranks B, so those first 70 votes will go to A. In the second column, again we've got A is above B, so those 60 votes will also go towards A. In the third column, A is above B, so those 50 votes will also get attributed to A. In the last column, however, B is the first rank, A is the last, so those votes will not go to A. So in that battle, A wins. Now let's look at A versus C. In the first column, the first ranked ballots, A is above C, so those 70 votes go to A. On the second type of ballot, again, A is above C, so those 60 votes will go to A. On the third type of ballots, this time C is above A, so those 50 votes are going to go towards C. And on the final ballots, again, C is above A, so those 45 votes will be going towards C. When we add up both, we can see that A wins again because it has more votes. Now let's look at A versus D. In the first column, A is top, D is at the bottom, so A will get those 70 votes. In the second column, D is at the top and A is right underneath, so the 60 votes will go to D. Third column, D is again above A, so those 50 votes will be going to D. And in the fourth column, D is again above A, so the 45 votes will also go to D. So this time, A only has 70 votes, but D has 155. Therefore, we can say that D wins in that case. So we've now seen that A is not always the winner. It won against B and C, but not against D. Now we need to go through and see if there's any other choice that is undefeated. Well, because A beat B and C, I'm going to start with D because as we already know that C and B are not undefeated. So now what happens if I go through and do D versus B? So on the first ballots, I see that D is ranked last and B is ranked second, so those 70 votes are going to go to B. On the next ballot, D is ranked first and B is ranked third, so those 60 votes are going to go to D. In the third column, D is above B with 50 votes. Those 50 votes go to D. And finally, the last 45 votes, B is above D, so those 45 votes go to B. So we end up with 110 votes for D and 115 for B. Therefore, in that case, B wins. Now this is where we run into a bit of a problem. We've encountered what's called the Condorcet paradox. We found that in comparison, if you compared A versus B, more people preferred A. And if you compared B to D, that more people preferred B. However, when you compared D to A, more people preferred D. So there's no clear winner. So no one choice or one candidate defeats all of the other candidates in all circumstances when you go in a head-to-head competition. Add this to your memory aid. Try the practice questions in the workbook and check your answers against the answer key.